How?
There are
Which
experiments.
experiment has showed Earth's orbital
There are
velocity?
experiments have been performed that show the Earth is a globe and is in motion and is orbiting the sun.
Bro,
So you're saying
which
that when I look,
experiment shows Earth
I,
has an orbital velocity
which
or a
experiments show that
detectable?
the Earth is flat?
All
So
right,
we got two, not orbital velocity,
so
the
like I said,
shape
you
of the Earth.
walk outside
Don't
your
go
house, the ground's not moving beneath your
right.
feet, you don't feel any motion. You look up, you see objects moving around your head, around you.
Mm-hmm.
When you go look at for any experiment of Earth's motion, all experiments have failed to detect Earth's orbital velocity.
That's deja vu because that's not the case.
Well, if
That's
you
not the
can look it
case.
up and find me one, that would be
Go
great. That
look
would
at
be mind blowing.
Google and say, how do we know the Earth is spinning? How do we know the Earth is rotating?
No, I want to see if there's an experiment like terrestrial or optical that we can tell and see
There
has
are
Earth's
both.
orbital velocity ever been detected.
There's you
And
go into
does that
orbital
match our
velocity.
senses? We feel still, and the testimony of all experiment of all time backs that up.
Wrong. That is not true.
Provide one
That's the
because
third
I'm saying you're
time.
wrong,
I'm sorry. I'm
and
not
you
getting.
can't
I didn't
provide
mean to
one.
be. I was just being strident, not angry. But that isn't true. You're saying I've drawn this conclusion about the Earth because there's no experiment that proves this. When there are experiments that have proved that thing that you're just saying isn't true.
Can you provide a single one that
Yes.
that shows
Google is
that
your
detects
friend.
Earth's
Go look on
orbital
Google.
velocity?
Go look on Google. I'm in my garage.
You're saying go look on Google,
Yes.
but I'm telling you there's none. You can't find one.
Okay.
Why would
Fine.
I look
So
on
go
Google
look
for something you can't find?
What are we
because you
looking
can.
for?
We're
So
looking.
that
We're
and
looking
it just
for evidence
there's
that the
not
Earth is
one
moving and is
experiment
orbiting
that
the
has
sun.
detected Earth's orbital velocity, terrestrial or optical. So
I
if
think
you
he's
could
going with
find
Einstein's
one,
thing. I think he's paraphrasing Einstein's quote.
I mean, you could paraphrase plenty of physicists. They all say the same thing.
Actually, but
It's all
I don't think that's
relative.
true.
They'll just
They,
say
Well,
it's all relative
if you
to
could
the
Go
find
on,
findings.
Jesse.
because
Let's hear it. Do you have a better mind than I when it comes to recalling stuff like that? I would have to look up on Google.
I did not hear the question.
No. So the question is, the accusation is, the claim is, that the thought is that when we go outside, we see the ground is not moving. We look up, we see these things moving, but there's no one has ever proven that the Earth is in motion. It seems flat and still. Okay, but no one's ever proven otherwise. And I'm stridently
Jesse
saying
knows not
that's
to
not
argue
true.
this point.
Well, but we agree that it does measure as rotating, right? We're only contesting
Yeah.
the. We're
Well,
only.
it doesn't measure as rotating. There's a sidereal rotation measured.
I'm talking about the 24-hour day rotation. That we agree that that's measurable, right?
That's just the movement of the stars around Earth, though.
Why do the stars push on my gyroscope wheel?
I'm getting 2017 vibes.
Why do the stars push on your gyroscope wheel?
Yeah,
Did you isolate them as an independent variable? Did you test that? Can you prove that?
Well, what I did do
Because I
was
see the stars moving around. I don't see myself moving around.
So what I did do is I took 3 vintage air-powered aircraft gyroscopes down into a concrete basement below ground, and I set them up, and I measured the rotational motion of the Earth using those.
Right. Okay. So what are you saying? What effect did you see in the gyroscope?
An apparent drift of 15 degrees per hour.
And you're attributing the cause to be Earth's rotation?
Well, there is only one known demonstrable cause for apparent drift on a gyroscope, and that is observer rotation. So,
okay, so you're attributing Earth's rotation to the effect in the gyroscope.
Yeah, that is a very valid form of measuring observer rotation. Yes.
Okay, so did you isolate that? Did you isolate that cause, that independent variable, so you can manipulate it and prove that it's Earth's rotation that's causing the effect?
Go to a different latitude.
if you put a gyroscope on a turntable and you turn the turntable, the gyroscope doesn't move with the turntable. It resists the rotation of its reference surface. Yeah, we know that about gyroscopes. That's how you can use them, say, to orient things without being able to see where things are. So, and as you
have
pointed
you
out,
ever
that's
heard of
the
the
only way.
scientific method, Pazza?
Any what? Sorry.
You know
Is the
about
gyro
dependent and independent variables?
is the
Yeah, but
gyro in Earth's frame?
you're gonna have to you have to listen to what he told you. Okay, right? If you spin up a gyroscope, yeah, and it drifts, okay,
Okay.
then
Right.
the only way we know how they drift. They drift in such a mechanical way is if mechanically the surface underneath it is rotating. We don't know of any other mechanism.
What do you mean? I could just say you guys say it's due to Earth spin. That's an unfalsifiable claim. You can't
You're not
isolate
listening to
that
the
as an
statement,
independent variable. I could just attribute it to the whole entire universe rotating around Earth.
Well, the difference
The
is
same unfalsifiable claim.
But how can you? Okay, go on. Yeah, go on.
I can change my observer rotation relationship to the gyroscope, and I can control for that. And so I can positively prove that the apparent rotation of the gyroscope does, map to my observer rotation. We cannot stop the stars from turning, so I'm not sure how you can control for your claim any better than I can control for my claim, and at least I can control for my claim a little bit.
No, I
What
said they're both
frame?
unfalsifiable claims.
Of course they are.
Mine is actually grounded in our senses and reality. Yours is
Well,
a fairy tale that you can't prove.
It's not. Listen, if I put a gyroscope on a turntable and I move the turntable, I move the thing under the gyroscope. The gyroscope doesn't move with it. Okay, that's what we do know. A gyroscope will resist the motion of the reference frame it's fixed to. That's all we know about them. We know no relationship with the rest of the universe in that gyroscope. We know the relationship with the gyroscope and the thing it's mounted to and how it reacts to the thing underneath it moving. That's all we know.
So you're saying that you're saying one thing, and Jesse's saying another thing. Jesse's saying that that what we know already. If you put a gyroscope on a thing and turn the thing, the gyroscope will measure that turn. You're saying that the universe is doing something. One,
No,
I think, has.
No, I didn't say that at all. I said if I
No. I was talking
saying?
to the other chappie. The other chappie, the flat earther chappie. Can't see his
What?
name.
No, I just said he's attributing the effects in the gyroscope to Earth spinning.
Do you think
I said
that's
you can't prove that
unreasonable,
because you can't isolate the independent variable. I could just attribute any
God,
change,
not
any
this,
effect that I want. I
not
could
this
attribute it to
again,
the whole
dude.
universe rotating around Earth.
Does it turn upside down?
More grounded in our senses of what we feel and experience.
The gyro flips all the way around.
Wait, hold on. No, hold on. Did you just say our senses and what we feel and experience? Is an airplane
Do you
moving?
feel the Earth rotating? No, you do not.
Do you feel an airplane moving at 500 miles per hour? No, you
It
don't.
doesn't matter. I'm talking about just
feel
our
a plane
natural senses,
moving.
what we
You
No,
can't
you
feel.
feel a
can't.
plane moving when you're on it? You're out of your fucking mind. That's like saying you can't feel a car moving. Of course you can.
You can't. You can feel the bumps. You can't feel the speed.
You can tell
you can
you're
gauge
moving.
the speed. If you're in a very fast car,
If you're in a
you can
plane
gauge
and you
the speed
can't tell you're moving
by the violence of the bumps.
You're
right?
hurting.
You
You're
can
in
gauge the
bad
speed
shape.
because of the wind around the car, right, and the violence of the bumps because they're more right. They'll shake you a lot harder at high speed. But
no, any acceleration, you're gonna feel it.
Accelerating.
Decelerate. You're gonna feel it,
Dude.
The
Yeah, in an
plane
airplane, you're not accelerating.
Yeah, but
And-
you're moving
and we
left and
can't-
right too. The wind's blowing. You have turbulence.
No.
Yeah.
Oh, you don't have
But you
turbulence.
can't feel.
You can't tell if you're going. If you've ever been in a plane with really smooth air, other than the noise of the wind rushing across the fuselage, you cannot tell you're moving. If you've ever been in really still air, like literally, your cup will not have any water like resonating inside the cup.
Dude, you can feel the up and down
Like
alone.
I've been in that.
Yeah, it feels weird to walk to the bathroom. Like, you're a
Not
little
in
bit
really
off
smooth
balance.
air.
Like,
Okay,
you can definitely tell you're
On a
emotional.
night flight,
No, Locksmith.
really
The
smooth
reason,
air, no.
Locksmith, the reason it feels weird to stand up on an airplane is because the engines are doing this funny thing called vibrating.
Also, you have lateral G, small amount of measurable pull forward at a constant speed, I would say.
All right, so
I mean,
I didn't board the airplane though. I just walked outside
there is
my
a
house.
small
No
amount
reason to
of
believe that
acceleration
I'm
and
in motion,
deceleration in an
especially when it
aircraft
doesn't match
every now
any
and
of the.
again.
What? I'm just saying I didn't board the airplane. I just walked outside my house. I didn't board an
But
airplane. There's no reason to believe that I am in motion, especially when there's no test or experiment that can prove it.
Locksmith,
So
I've
Occam's
explained to you that
razor,
there is.
the
It's
least
called
amount
a
of
ring laser
assumptions, we're
gyroscope,
not
or a
moving.
mechanical one like the one that I used. Now, don't ask me, did you friggin' like the independent variable? Yes. Yes, I did.
No,
The
you
independent
didn't.
variable is called the latitude.
No, it's not.
Bro, we went over this yesterday with you, Grumman. Don't tell me that you've forgotten what happened yesterday. Please.
Geo,
You
I
retreated
posted
yesterday.
Geo, I posted basically the rundown of the experiment.
Yeah, so all that does is it says that you think the change of latitude is the cause of the effect. That's all you've done. You haven't actually found the actual real cause.
No, Geo, the thing is, if the change in precession based on the latitude matches up with what we would predict from a rotating Earth.
Yeah, it's a loose correlation.
I mean, did they even account for the oblateness in the southern hemisphere compared to the northern hemisphere? And did that correlate within your chart or your documentation? Because I doubt it did. And if it didn't, then your whole thing's up for question.
How much would the oblateness manifest in terms of a difference between in a northern latitude and longitude latitude?
Well, when we're dealing with angular rotation, the diameter of the thing in contention is going to play a significant part in, angular velocity of rotation.
Yes, that's why change of latitude is a variable in this experiment, because because the rotation speed does change very minimally, because the Earth is oblate very minimally.
And that shows up in your calculations. That shows up within the precession rate. Can you show that? There should be a difference from north to south.
He doesn't know how to do an experiment. He doesn't even know what an independent variable is.
Locksmith, I explained what it is.
No,
Because
you
I
didn't.
actually passed fifth grade
It's
science.
the cause of the effect. You're saying the latitude is the cause
Now,
of the effect.
if you're going to stop asking me,
we're trying to prove the
do
dynamic.
you know what the independent variable is? I've explained this to you. I've explained the way the experiment works. I've explained to you what the variables are, and I've explained to you that a variable is not the same as the thing you are testing
doesn't
for.
mean you explain correctly. It's embarrassing. The latitude is not the independent variable.
Locksmith,
the cause of the effect, the thing you're trying to prove, is Earth's rotation. You're claiming that's the cause of it.
Which isn't a variable.
So how would you isolate that cause? How would you manipulate that effect?
Dude, you don't, because it's not a variable. It's the thing you're testing for.
Oh man.
That's the hypothesis, isn't it? I mean, like you say, if you just had one pendulum and you met a Foucault's pendulum in one location and you saw a rotation and you measured the precession, that's just an observation. But then if you had in your mind a notion that the Earth was a sphere, and you looked at the mechanics of what would happen if that was in different positions on it, and you could come up with a hypothesis that, as I move north and south of here, there will be a difference in the way it behaves. That's the hypothesis. So how do you evaluate that? How do you evaluate that? If that was your position, you would have to take the same piece of equipment somewhere else. Now, the control variables would be making sure that you use the same piece of equipment and it keeps its calibration as best you can achieve. So you engineer it to the precision that you need to be satisfied that it's staying within those control variables. The independent variable is you moving it about.
And then, the dependent variable is how much it precesses.
Yeah, and if you make a load of observations and they correlate that hypothesis, then
So
you've
then, just moving around the latitude and with a non-rotating Earth, it would do the same thing then, because you're not attributing the cause.
okay. So what's the what can you so the focal surmise that the position on a rotating spherical geometry would cause a different type of precession, and he demonstrated that with maths. He came up with a mathematical proposition for that, and it satisfies everybody understands these things. Yeah, in the scientific world, no one's going, hang on, I got that wrong. This isn't true. So when someone comes up with a hypothesis that comports to that from being on say a topologically planar surface, then you'd have something to go on.
No,
If you got a flat
don't.
surface and
You need an
if you got
actual valid
okay,
scientific experiment to
mate,
prove something.
no.
You can't just go.
Let me
You can't just have
finish.
a hypothesis and that's
Locksmith.
it, and then just draw your conclusions.
You just troll
You
through
need an
people. Why not?
experiment.
Okay,
Huh?
Locksmith.
If you're on a flat surface with a gyroscope, like a big
This is
turntable,
too easy. I mean, it's just so easy.
all right, carry on,
It's
Locksmith.
so
Off
easy.
you go. Yeah.
All right,
Stopping stopping people talking must mean you've won.
No, it's just
Okay,
so
Locksmith.
easy to
Let's,
defend the truth right here.
I think
hold
Grumman
on.
wanted to jump in. Drummond
Yeah,
wanted
no,
to
Locksmith. Let me try and explain this to you in probably the simplest way I can.
You gotta explain it correctly, though. Just don't explain just random stuff, okay?
You're gonna call what I
Or
explain random stuff.
I'll end up explaining it to you.
Locksmith.
Go
So
ahead.
the hypothesis
Go ahead, buddy.
in this case would be Earth rotates differently at different latitudes. Right?
What? It
The way
rotates
to
differently
test
at
that
different latitudes?
is
Alright.
take a gyroscope, measure it at one latitude, see how much it precesses, right? Or rather, we would expect the Earth to rotate at a different rate at different latitudes. So you take that gyroscope, you measure it at the precession at one place, and then you go, it precessed. Take it to another place. If that precession is different, depending on if you go north or south, right? Then you go, the hypothesis of the potential, like we would expect Earth rotating to change. So we move latitudes, and the precession on the gyroscope has changed. So what would you think that would mean?
Does it go all the way around?
This
I'm
is
sorry.
brutal. So yeah, what is the cause you're testing for in the experiment?
If the Earth's rotation is what's precessing the gyroscope.
Okay, so Earth's rotation you're attributing as the cause of the effect that you're seeing. Right?
No, the latitude.
You just said it was Earth's rotation.
I did mention that earlier, by the way. I did say latitude. You changed your latitude because you said what was independent variable. Jesse said latitude change.
Yeah, latitude. So you're claiming it's latitude?
Yes.
You wanted an independent variable.
Latitude
Locksmith.
is the cause of the effect that you're seeing.
It would be because Locksmith, the effect that we're seeing is change in precession on the gyroscope. So the cause of that would be change in latitude. Right?
Okay, so the cause
and we would
is now the
expect
change in
a
latitude,
gyroscope
not Earth's rotation.
to change its rate of precession
Okay.
from a rotating Earth at different latitudes. So if the gyroscope shows that, what does that mean the experiment has proved?
So if latitude is the cause, latitude is the
Locksmith,
cause.
answer the question. What does that mean that the experiment has
If you're not
proved?
listening, please don't interrupt him. He's actually was speaking and you just overtalked him. Go ahead.
He did the same thing to Paza, so.
That doesn't count, does it, Gio?
Latitude isn't the cause.
I don't know what you guys are talking about, but if I mention someone's interrupting to just make some claim that someone did it 5 minutes ago is not valid. Go ahead, Locksmith.
No, I'm just trying to figure out what you're claiming is the cause of the effect that you're seeing. Because first you said it was the Earth's rotation. Now it's latitude. What are we going with so I can, argue against it?
Geo, the effect is change in precession. The cause is latitude change. And we would expect the latitude change to change the rate of precession on a rotating globe Earth. So if the gyroscope does that, what does that mean the experiment has proved?
Not Earth rotation.
Aye,
All you've proven is that precession.
Actually, that is the exact opposite.
If
All it does is-
latitude's the cause, you would see the effect change on a non-rotating Earth as well. If you're
No,
not,
you wouldn't.
Why?
Yeah,
Why?
you're not-
What makes you say that? What makes you say that?
What would cause it to happen? What would cause the rotation, or I mean the precession to change on a non-rotating Earth?
that's what you're testing for. You said the cause that you're testing for is Earth's latitude changing, not
Could I-
The
can I
cause
put-
that
causing
we're
the effect.
testing,
Please, Jesse,
I'm
save
sorry,
us, Jesse.
causing the effect.
the
Can I
cause
put
that
this-
we're testing for, Locksmith, is Earth's rotation. The way we
Oh my
test
God,
it
you keep
is we would
changing. It was just
expect if Earth
latitude.
were rotating, for
If-
latitude change to change the rate of precession. Right?
Well,
So
let
if
me
rate of
just-
precession changes,
You're all over the place,
Can
bro.
I just get there? If you had
He's
a
not
very
listening.
large turntable, very large turntable, and you put a gyroscope anywhere on that turntable, and you turn the turntable 15 degrees an hour, you'd expect a precession from the respect to the surface of the turntable. The gyroscope would resist that rotation. You'd see a drift of 15 degrees an hour. Doesn't matter where you put it on that turntable, it's always going to be 15 degrees an hour if it's a flat return table. That's how that works. So the hypothesis could be, if I'm on a flat Earth and it's rotating, and that's the cause why I'm seeing 15 degrees of resistance with respect to the surface I'm on, then if I went everywhere and it was 15 degrees of precession everywhere, that would be a demonstration that I'm on a flat Earth. That's how that hypothesis would work. Now, if you are on a larger sphere and you at any given point your gyroscope changes orientation because you're on the surface, the maths and the physics will tell you that the precession will be different in different places. In contrast to it being the same everywhere, it would be on a big turntable. Those are two
That's-
hypotheses. You can test them, and you can test them simultaneously. And when we go around the world, the precession changes. So one of the hypotheses holds true, and the other one doesn't. It doesn't prove anything. It demonstrates potentially something, doesn't it?
Jesse wanted to get in as well.
Oh, I
Well,
just
you
wanted
just
to.
we
said
were
it right there.
confused.
It doesn't prove it. It just demonstrates potentially something. You said you worded it pretty well there. That's all this does. It demonstrates potentially something that might fit into a model that other people have told us, and you kind of want to go with it because it's like your belief system. That's like the
let's
best.
go
we
to
got.
let's go back to you're right. Let's go back to talking about a Pac-Man.
Jesse wanted to get in.
All right, that's just disingenuous and psychotic that you just said that because we're not talking about that at all. So, are you having a psychosis break or?
okay, Geo,
Okay,
just
upset.
this
you.
is
You just said
That's
something about a
Geo.
unnecessary.
Pac-Man video. Wait, he just said
Geo,
something about
if you're going
Hold on, he
to
said
call
something about
people
a
out,
Pac-Man video game, Pezza? What is
What were you
that?
talking about last night? You were hypothesizing that the sun could be Pac-Manning around, just like Pac-Man, because that's how it works.
No, I absolutely was not doing that. You're being incredibly disingenuous right now.
Oh,
I specifically said that I've never claimed a Pac-Man son. So why are you being deceptive? Are you doing
you were
that
doing it last
purposely, or
night.
are
You were
just
saying that could be
troll?
a hope. That could be how it works, like
That's not what
Pac-Man.
I said. That's not what I said. I never said that. I specifically clarified and said that I did not. So you're just an incredibly bad faith, disingenuous person that's just trolling and lying.
Aye.
Of course, Gio.
Yeah, you are.
Yeah,
That's absolutely vile.
Jesse-
I've got
Jesse
a
wanted to get
memory.
in.
Gio.
Geo,
It's absolutely vile.
this
truly
is your
it's
server, so
awful,
you get
Gio.
to.
It's awful.
You
Yeah,
get to, don't
disgusting.
trigger him. Pazza, don't.
Absolutely
I
disgusting.
would like to hear from Jesse, please.
Well, that's fine that you would like to do that. So what Paz is doing is like he's using like ridicule based assaulting sort of rhetoric from something I never said, and he's trying to apply it to me. And then he's like doing what's called troll stalking, which is like you stalk someone and you kind of like continually try to like give this lie or deception to try to like trigger them. It's very, very vile. I don't know why you'd think that we'd want to spend time with you at all in here if that's what you're doing. That's just awful. Like so disingenuous and deceptive. Wow. right when you got to the point where you couldn't prove the gyroscope thing, you just pull up a Pac-Man Sun to do some like ridicule-based attack that's just based on.
Are you done, Geo? Are you done?
You're dumb, bro.
Done, not dumb. I said, has he done? Has he got over it yet?
I said
Well,
you're
it's like,
done.
what are we doing? Like, I'm spending my life with you, Paz. I'm spending some time with you. You know what I mean? Like in this environment. So why would I want to spend time with someone who's just being like lying, deceptive, trolling, and just doing?
If you're gonna kick me, just get on with it and stop all the bloviating.
Pazza, it's not the thing to say if you unless you want to get kicked.
What if he wants to do it? Do it.
I know, but it's his server.
Let him get on with the conversation we were in.
It's his server. He gets cross quite infrequently. It should allow him to get cross once in a while. He's done it to me. I was like, okay, he doesn't do it very often. He's very very even tempered.
Well, it's just like when you're spending time with someone, it's like when you're spending time and like, you know, I mean, like you're a guest, Pazza. You know, like you're a guest here, and you're spending time, and so like yesterday, like okay, the Pac-Man thing is like a ridicule-based thing that's been thrown around because people like with the dual pole they explode and they have to say Pac-Man. I've never claimed a Pac-Man. I've corrected you like 6, 7, 8, maybe 10 times that I've never claimed that. However, you just continually want to apply that to me. It's just incredibly deceptive.
I've not said it 7 or 8, 9 times. Do you remember the class conversation we had? We were talking about the fact that the dual pole map has got the equator going off one side and coming on the other. And you picked up on the fact that I said the sun would have to Pac-Man from one side to the other. And what did you say? Do you remember?
I don't know. You've just destroyed the conversation. So we were
talking about
other stuff.
That's why I was, with respect, Gio, I was trying to get Jesse in because he's usually distracts us from you know when we're.
Yeah, there's just some very vile characters in these discussions, just deceptive, demonic. It's very unfortunate. It's like you try to have an opening place and everyone's welcome, and then you just have these people that are just like troll stalking and just, it's insane. It's so disingenuous. And then what do? Like, just let them do it every day, or? Yeah, I guess
don't do it every day. What do I do every day? I'm not here every day. Don't exaggerate.
Not making it better, You're not helping. All right.
Well, it's just sad that we were talking about how it's like the gyroscope thing is just like a correlation to a model. And then instead of Pazza just being genuine and being like, yeah, I agree, he had to be like, oh, you say a Pac-Man Sun, when I've clarified for him multiple times I've never claimed anything about a Pac-Man.
To be clear, I was the one that you picked up on that stated it correlates and demonstrates something rather than being a proof. I said that. No one else.
So I think, who was the one that brought up that the
yeah, so you admit it doesn't prove anything.
Yes, it doesn't prove anything.
Who is the one
it's not proof of Earth rotation. That was the original question.
It's a demonstration of it. It's an evidence for Earth rotation.
I mean, that is all we can do. We can gather evidence and draw conclusions.
Yeah, but we're trying to get to what the truth is. So what I was going to say about that before you went into your Pac-Man troll stalking thing, what I was going to say before is that if somebody had a theory that it was like ether drift and that the ether drift changes due to latitude, you could say the same thing. You could say, well, we would expect that with the ether drift that changes via latitude, we would expect that the precession would change via the latitude. That would be the same thing. It wouldn't be proving it. It would just be a loose association. So if somebody's trying to claim, that it is ether drift and that's all they're using, that would also be invalid. So if someone's trying to claim that the Earth is rotating and that's all they're using, it's also invalid.
Okay. Well, what's ether and how do you know it drifts with respect to longitude? What gives you that impression it would do that?
I'm just using that as an example. I'm just saying that it could be something. For example, in the whole thing with the whole precession, let's say it was ether drift. Let's say that's the actual truth of what it is. Then folks claiming that it links with a rotating globe Earth would just be faulty It means you would not be getting to the truth. So it means all these years claiming it, you would have just absolutely failed to get to the truth if it is not actually the cause. And that's the whole point of the scientific method, is actually getting to the cause and actually being able to isolate the cause.
But we can't detect ether. And even if we could, we definitely, as a consequence of not being able to detect it, don't know how it behaves, and we certainly got no evidence or no ability to discern that it changes anything or manifests anything with respect to longitude or latitude. None of that, because we do. If you might as well be talking, say, unicorn. With all due respect, you could say unicorn farts, because we've not detect them and we don't know what they are or how they'd affect anything. So you can come up with a million and one things. However, what you do know is when you rotate the surface on which you mount something like a gyroscope, that manifests itself in a resistance to the rotation from that framework of the gyroscope. That's all we know. We don't know about any other effects affecting the gyroscope because we haven't measured anything else.
What frame is it in?
Well, when it's on a desk in a lab, you're observing it with respect to where you're stood in the lab, aren't you?
So it's in the same frame as the lab?
Sure.
That's a problem.
Its rotation is the only thing we do know is that if you put a gyroscope again on a turntable, you can from the perspective of to being on the turntable, if the whole turntable revolves, you can tell how fast the turntable is revolving because the gyroscope resists that rotation. It rotates independently of a reference frame.
What's it in reference to? What's it calibrated to?
What does that mean?
That means, what is it set to do in the first place? Why does it behave the way it does? It's not like they took a bunch of pots, threw them into like this little thing, and now it does this magical thing. No, they have to calibrate it, right?
Oh no, you don't have to calibrate anything. You set a gyroscope spinning.
You don't calibrate a gyroscope.
Okay. You engineer it so that you calibrate at the precession when you engineer it. But when I get in a gyroscope that I've been manufactured and I spin it up, okay, it's just sitting there spinning up. And then if I move the surface, okay, go on, carry on.
But you're going past it, right? I'm talking about the calibration, the original orientation they set it to before it ever touches your hand.
Calibration.
There is no original
part of the
orientation.
manufacturing process of it. They're going to orientate it in such a way. In relation to what?
What do you mean?
A presupposed notion.
A gyroscope has rigidity and space.
So it's in its own reference frame now. What about the helicopter? Is that in its own reference frame?
Is it rotating?
The thing with the gyroscope, though, if you give it enough time, it'll eventually flip itself over. So it's not rigid in the complete sense. It's momentary.
No, because
which is why we get the flipping of the poles from time to time, supposedly. It's the same thing. It's gyromagnetic precession.
Long enough to get a reading from it.
Right.
Long enough to get a valuable reading from it.
Right. So you're not traversing with it. You're just trying to set it up in key points along the longitudes, right?
Well, again, the basic concepts are that the Earth is rotating, and if the Earth is rotating, certain things should happen, and we can test with those things. There's other hypotheses, right? But there's other hypotheses, but they don't have explanation. They have a lot of all the type of assumptions and creative ideas behind them, rather than just the explanation is simply the Earth is rotating. Nothing about the universe or anything like that. Just the Earth is rotating.
Well, like I told you, dude. Like I told you, there should be a difference in precession from the north versus the south due to the oblateness of what your model claims.
Dyslow, there is. That's the point of the experiment. That's the point of moving latitudes. That's
you claim that. You claim that, but I don't think that's been done.
What do you mean you don't think it's been done? Gyroscope experiments on Earth's rotation have been done by many people on different parts of the planet.
What about the?
That's the
What
crux
about?
of the issue, though, isn't it? The crux of the issue is that there is somehow permitted an ability to simply just say, no, this isn't true because I don't want it to be true, when talking about experimental things that are being done. And then the highest degree of scrutiny is applied to that, whatever it is, because it shows that the Earth is rotating. That's I don't know. Go on, Jay. Sorry.
But it
I was going
doesn't
to say,
show
if you
the
don't
Earth.
like the
It doesn't show that
gyroscope,
the Earth is rotating, though. We just went over that. Paz just
what
admitted
about?
it doesn't. It's just a
Yeah,
loose
no,
correlation.
it does
doesn't
show it
actually
is
validate
rotating. Geo, it demonstrates that the Earth is rotating. It is a demonstration of Earth's rotation.
It's an evidence, isn't it? That's all you can really. If you're truthful, it's an evidence that that's occurring. It's an evidence that you're not on a. It's definitely an evidence from what you'd know about how a gyroscope would behave if it was moving around a plane.
I mean that's it's the same way that is the case. It's the same way that we sort of figure out that by looking up we can see what the ground is, because looking up we can see that objects behave a certain way, which matches what we would expect to see on a rotating sphere. We'd expect two poles of rotation. We'd expect two sets of stars in both locations. And those seem to back up Earth being a sphere and in motion. I still want to hear from Jesse if he's still here. Doesn't look like he is.
Yeah, according to my calculations.
Oh, no, yes, he is.
I'm here.
All right.
According to my calculations.
That was a good one.
But I did eventually put my statement into the text. But for the listening audience, I would like to go over it. I'm actually going to disagree a little bit with some of the globers here. Just a clarification, the 15 degrees an hour that a gyroscope shows due to Earth rotation or star rotation or whatever it is not precession, because precession is caused by a force, a rotational force on the gyroscope, a torque. It is actually called apparent drift because it's obviously drifting, but it's for no known internal reason. It's not due to imbalance, it's not due to a force, it's just locked to some other inertial frame. So it's not precession, it's called apparent drift. Real drift is when it actually is drifting due to a torque, which is a precession, but apparent drift is what we're talking about. As far as moving it to different latitudes, that's really not controlling for whether, the cause of the rotation. It's just controlling for the axis of the rotation, and that would be an experiment to show that the axis of the rotation is aligned north to south. And neither the rotation of the Earth nor the stars can be stopped or controlled for. So the claim that it's the stars or the aether rotating is that there's no that's not the scientific method either. However, the cause and effect relationship of observer rotation and the gyroscope's apparent drift can be tested. I can rotate myself around the gyroscope and see that it shows my rotational speed. So at least that is a known, and it's the only known cause for apparent, it's the only known testable cause for apparent drift in a gyroscope. So it's not at all unreasonable to say this is evidence for Earth rotation, since the stars and the aether cannot be stopped. We really can't say whether or not there's even any reason to say that. But observer rotation is definitely something that would cause that effect, and we know that. So that's all I had to say. And thank you.
We should also bring up. We should bring up the drop power tests as well, which have been done many different times, in different periods. There's a recent one I can show that a German university did a few years back, and it shows the deflection in the direction that we would expect, and the magnitude correlating to their latitude.
What happened?
You're not familiar with the drop tower test?
The one in the vacuum? Where the feathers move?
No.
Which one, Jake? There's a bunch of them. One of them, they drop an object in the same location and it falls at different rates depending on what time it is and what's happening.
No. This is a googly, I forget what it's called, but I can post you guys links to some references of it. It's where they drop ball bearings within a tower, and then they look at the deflection from directly below.
I would like to hear.
Oh, you're saying they're not falling vertical. You're saying they're not
falling
right.
They're not falling directly vertical. No.
Yeah, they're deflecting
from a plumb line.
Hey, sorry,
are they deflecting from a plumb line? Just real quick. Yeah, right.
Yes, exactly. Deflecting from a plumb line.
So that means gravity no longer pulls things to the center. It doesn't have enough force to counteract the rotation of the planet.
It would just be an illustration of conserved angular momentum, or actually conserved linear
it
momentum.
It would be
exactly.
rotation. It would be the influence of rotation countering gravity, is what it would be.
Nothing countering gravity. That's silly.
Well, it does. If it doesn't go straight down, it does.
It's similar to Coriolis.
When you drop something, you've got what's called I believe it's called the Magnus effect.
Magnum PI?
No, maybe it's the Magnus effect.
The Magnum.
Unless
effect.
the ball's not spinning. If it's just stationary ball, you might not get that effect. But if you're saying things are dropping off to plumb, falling and not landing on where plumb is, like
they just threw away plumb forever. They need to
recalibrate.
They need to recalibrate plumb everywhere.
Why isn't the plumb line? Why wouldn't the plumb line be hanging in that spot then?
It'd be in a perpetual. It'd be lagging behind.
If you drop, no, you're not understanding what I'm saying. You drop the ball bearing. They're saying it drops off a plumb line, but if you were to just drop the ball bearing with a line attached to it, it would be in the same spot, right? I don't get how it's falling off of plumb.
Why is the? Yes, that's what I'm saying. You lost.
You understand what I'm saying, Jake? Hold on, Rigger.
Think of it as a vertical.
No, it's literally Coriolis. It's the same thing as why when you throw a bowling ball, when you let go of a bowling ball, it doesn't land right where it doesn't land directly under your finger.
I know, but Jake, if you had a plumb line, let's pretend you had a plumb line, and you drop this ball bearing from the ceiling, and let's just say it has a rope attached to it, it's going to fall at the same spot. Your one without why would it be in a different spot than the ball?
Because the plumb line is attached at the top, and is then in the reference frame of the rotating Earth, whereas the falling ball bearing is not.
What about the
pendulum? But you're not understanding.
What Jeremy is saying is correct. If you had a plumb line, hold on a second.
Okay.
Yeah, there's no reason why the yeah, I'm usually always right. 60% of the time, 60% of the time I'm right every time. But
maybe 40.
The thing is if you were to drop a plumb line there, why wouldn't it be let's pretend the ball bearing was the plumb line. Why it's going to be in the same spot. That doesn't make any sense.
My tiny brain thinks I'm understanding. I think it's because the plumb line is attached at the top. Okay, so it's rotating with the Earth, and the plumb line will simply point towards the center of the Earth.
And now you're throwing out
but what happens is when you
pendulum.
Hold on. Wait. What happens is when you drop the ball bearing, it does fall towards the Earth, but the Earth is also rotating, and so it is no longer it is no longer attached to the Earth in that way. It's a bit like Coriolis. And it's
It
also,
doesn't even know it's attached. It wouldn't even know it's attached until the last second. And at the last second, it would be right where the other ball bearing fell. Like there wouldn't be a difference from where you dropped it to where the plumb line is.
I think one of us needs to sort of take a look at that. I can't do it right now, but one of us needs to take a look at it and see if they can figure out the Magnum effect. I think the Magnum effect is
you're
required
I don't think
to
that's even.
be on.
I don't think the Magnus effect is applicable, dude. That's only if the ball's spinning.
it's not.
If they're dropping it, not
Okay,
spinning.
Okay.
Well, what if it took 92 minutes to fall? That would have been a different spot.
No matter what, if you have a ball bearing, and then you have a ball bearing with a rope attached to it, they're both going to be at the same spot, right above the ground, right before they hit the ground.
Sorry,
Why would they be in different spots?
Jeremy, you're right. If you had a line that didn't impart any force to deflect the ball on its way down, if it was a line that had no effect on the ball, then it would deflect the same amount, and then it would rock, and then it would come to a rest directly plumb, which would be a different spot from where it originally came down on.
No, you can't. Why?
So,
why would you say?
What do you mean?
That?
Why?
Why would
that's
you
what these
even say that?
That's what these experiments show.
They have a plumb line there that with a string from the ceiling.
They string a plumb. I'll post the article here. It's in German. You have to run it through Translate.
All right.
How could you even settle the plumb
Get on
line
it, Jesse.
if you have that force pulling?
I mean, we could shift to this topic, but it was kind of a separate topic than all the gyroscopes and everything that we're talking about before. So, I mean, we should also leave room if anyone had additional comments on that as well. Or are we completely shifting to this? Because yeah, this is like a whole separate.
Kind of like another reference frame thing, right?
All right, I posted it. Yeah, so what they do is they I posted it in the live stream text. They run a plumb line down from the drop spot to mark the location on the floor that's directly plumb. And then what they do is they have like a holder for a ball bearing that's drilled very slightly smaller, or it's drilled the thing so that the cold ball bearing will fall right through it. So what they do is they heat up the ball bearing so it expands, and then they put it in the holder. And when it shrinks, so that it shrinks equally in all directions, it falls through the orifice so that they're not imparting any kind of a lateral torque on it as it's released, to try to give it as fair a chance of being released without imparting a force in any direction. And then it falls, and then they mark the spot where it falls. And that's a deviation from where the plumb line was. And that's due to the fact that since the ball was higher up, it had more linear momentum than it did closer to the surface. And that's why there's a deflection in the direction of the rotation of the Earth. And they drop a whole bunch of these, and then they draw a plot, and then they show what's the average versus what's the expected for the sign of your latitude.
Anybody, do you have like a English version?
You can just run that through. You can run that through ChatGPT or Google Translate. Translate the website. It'll translate the website for you. Just go to translate.google.com and type the URL in there. It'll translate the page. But this is an experiment that's been done many, many times. It actually predates Foucault.
Are you having to assume a radius when you use it?
Only if you're trying to derive a reference for the magnitude, but not for the fact that it shows a deflection in a certain direction. You wouldn't have to assume a radius. Only if you want to try to correlate it with the drop height versus what the magnitude is based on your drop height and what's expected on based on the radius of the Earth. But if you don't care, you can see that there's a deflection in the direction of rotation of the Earth.
The longest distances these have been performed.
Well, I'm not sure what's the highest drop height they've ever used.
Do you find there's a correlation between the drop in which the height in which they drop correlated to the rotation?
There's a correlation between the latitude that the drop experiments perform that and the height of the drop, which dictates the magnitude of the deflection.
Well, that would be based on a size, though. You would need a radius value to calculate that.
Only if you're concerned about the magnitude, but the fact that there's a deflection in the rotation of the Earth will show you that the ball is not falling straight down. Irrelevant of what the radius of the Earth is.
Is it just a ball that deflects in the manner as such that you suggest? Has it been done with other shapes like a triangle?
You would need to have something that's going to have an aerodynamic that's not going to be aerodynamically deviated. You're not going to be able to do that with a triangle, right? Because a triangle is going to be aerodynamically deflected.
But you would have different results. So therefore, if there's different results, that it's not unilateral.
Well, I don't know what you mean. Obviously, if you can't do this in a vacuum chamber, then the shape would matter because it's going to be aerodynamically deflected by the air. That's why you can't use a paper airplane to do this experiment.
That's why I ask about the overall drop distance, because it seems to be there's a limitation on how far you can drop items.
Okay, so what?
Maybe they can only be dropped within a certain range to fit within a certain probability prediction. And if they fall out or under that particular threshold, that the no longer presupposed radius works.
The radius doesn't matter. You have to figure out why is there a deflection at all.
Well, that's why you changed the shape.
What would the shape have anything to do with it?
Well, isn't it true that you're going to have different effects based on different shapes?
Well, if you drop something that's going to change the aerodynamic profile of how it falls so that it will deflect to one side or the other due to its aerodynamic properties, then you wouldn't be able to use this test, would you? So why would you introduce that variable? That's why you use a ball bearing.
I'm curious to know why other objects haven't been tested to come up with the same result. I see Kosho's back. Jesse, path of light or path of the string.
What's up, Dada? It's been a long time, buddy.
Then it's been a while there. How you doing? How's life treating you?
I've been better. It's good to be back around here, though.
How's your app? Did you finish your app?
You gotta be more specific.
Oh, you're working on some sort of AI app.
I'm working on a bunch of stuff, man. I barely finished anything I'm working on.
Do you find anything new about the flat Earth versus globe? Is there any new points of contention?
I've been out of this community for a little bit, man. I'm the wrong person to ask.
You must have liked the Antarctic chapter for sure.
Yeah, that's when I started missing out on all this, actually. Right before that happened. You know, it's always been my dream to go to Antarctica as well. That was exciting to me.
What would be well, how would you do it? I mean, obviously it's not cheap just to go there. The cruise is the cheaper option, but you don't really get to do much on the cruise. I think you get 3 days and they just take you to a port basically. What kind of adventure would you like? Like the 50 grand one where you're like 3 days?
No, I never thought I'd ever get an opportunity to go there. So I think if somebody actually wanted to go there, the best way to probably go would probably be to get a job, because that way you get paid to go down there, and you know. But I don't think I'd ever go down there.
What would you do for work down there?
A science job. There's a lot of labs down there.
Like what? What would you like to do? What would you?
I'll shoot porn down there.
Inside your house, the ground's not moving beneath your feet. You don't feel any motion. You look up, you see objects moving around your head, around you.
Mm-hmm.
When you go look for any experiment of Earth's motion, all experiments have failed to detect Earth's orbital velocity.
That's deja vu, because that's not the case.
Well, if you can look it up and find me one, that would be great.
Go Google and say, how do we know the Earth is spinning? How do we know the Earth is rotating?
No, I want to see if there's an experiment like terrestrial or optical that we can tell and see.
Yeah, there
has
are
Earth's
both.
orbital velocity ever been detected?
You go to orbital velocity.
We feel still, and the testimony of all experiment of all time backs that up.
Wrong. That is not true.
Provide one, because I'm saying you're wrong.
I'm sorry. I'm not getting. I didn't mean to be. I was just being strident, not angry. But that isn't true. You're saying I've drawn this conclusion about the Earth because there is no experiment that proves this. When there are experiments that have proved that thing, that you're just saying isn't true.
Can you provide a single one?
Yes. Google is your friend. Go look on Google. Go look on Google. I'm in my. There's no experiment that proves this. When there are experiments that have proved that thing, that you're just saying isn't true.
And you provide. Was the one that you picked up on that stated it correlates and demonstrates something rather than being a proof? I said that. No one else.
So I think who was the one that brought up that?
Yeah. So you admit it doesn't prove anything.
Yes, it doesn't prove anything.
Who's the one?
It's not proof of Earth rotation. That was the original question.
It's a demonstration of it. It's an evidence for Earth rotation.
I mean, that is all we can do. We can gather evidence and draw view, because that's not the case.
Well, if you can look it up and find me one, that would be great.
Go Google and say, how do we know the Earth is spinning? How do we know the Earth is rotating?
No, I want to see if there's an experiment like terrestrial or optical that we can tell and see.
Yeah, there
has
are both.
Orbital velocity ever been detected?
You go to orbital velocity.
We feel still, and the testimony of all experiment of all time backs that up.
Wrong. That is not true.
Provide one, because I'm saying you're wrong.
I'm sorry. I'm not getting. I didn't mean to be. I was just being strident, not angry. But that isn't true. You're saying I've drawn this conclusion about the Earth because there is no experiment that proves this. When there are experiments that have proved that thing, that you're just saying isn't true.
Can you provide a single one?
That's what we can do. We can gather evidence and draw conclusions.
Yeah, but we're trying to get to what the truth is. So what I was going to say about that before you went into your Pac-Man troll stalking thing, what I was going to say before is that if somebody had a theory that it was like ether drift and that the ether drift changes due to latitude, you could say the same thing. You could say, well, we would expect that with the ether drift that changes via latitude, we would expect that the precession would change via the latitude. That would be the same thing. It wouldn't be proving it. It would just be a loose association. So if somebody's trying to claim, that it is ether drift and that's all they're using, that would also be invalid. So if someone's trying to claim that the Earth is rotating and that's all they're using, it's also invalid.
Okay. Well, what's ether, and how do you know it drifts with respect to longitude? What gives you that impression it would do that?
I mean, that is all we can do. We can gather evidence and draw conclusions.
Yeah, but we're trying to get to what the truth is. So what I was going to say about that before you went into
and see
there's
both orbital velocity ever taken, and none of it has ever.
This, and I think this is really good, so I'm going to say it. So, Ixki, if you're
sort of ad hoc situation, they can
be that the scripture as it's written and is presented to you describes the boundaries for you.
Can't doesn't matter. I'm talking about just our natural.
That what we know already. If you go look at Google and say, how do we know the Earth is spinning? How do you know?
Yeah, the second kingdom that maybe Paz is asking about, which
I just wanted to ask Paz and Red Cloud, like, just a quick question. Like, when you walk outside of your house in the morning and you look down, the ground's still beneath your feet. You look up, you see a sun moving over your head. Then you go look at every experiment and measurement that's ever been taken, and none of it has ever been successful in proving the motion of Earth. Like, what makes you think you're in motion?
Because, with respect, the question is flawed because that is not the case.
How?
There are
Which experiment has showed Earth's orbital velocity?
Experiments have been performed that show the Earth is a globe and is in motion and is orbiting the sun.
Bro,
so you're saying that when I look,
experiment shows Earth has an orbital velocity.
Which experiments show that the Earth is flat?
So
we got two, not orbital velocity.
But like I said, you walk outside your house, the ground's not moving beneath your feet. You don't feel any motion. You look up, you see objects moving around your head, around you.
Mm-hmm.
When you go look for any experiment of Earth's motion, all experiments have failed to detect Earth's orbital velocity.
That's deja vu because that's not the case.
Well, if you can look it up and find me one, that would be great.
Go Google and say, how do we know the Earth is spinning? How do we know the Earth is rotating? No. You're saying I've drawn this conclusion about the Earth because there is no experiment that proves this. When there are experiments that have proved that thing that you're just saying isn't true.
Can you provide a single one?
Else.
So I think who was the one that we brought up that the
so you admit it doesn't prove anything.
Yes, it doesn't prove anything.
It's not proof of Earth rotation. That was the original question.
It's a demonstration of it. It's an evidence for Earth rotation.
I mean, that is all we can do. We can gather evidence.
Yes, it doesn't prove anything. Yes, it doesn't prove anything.
It's not proof of Earth rotation. That was the original question.
It's a demonstration of it. It's an evidence for Earth rotation.
I mean, that is all we can do. We can gather evidence and draw.
Yes, it doesn't prove anything.
Strident, not angry. But that isn't true. You're saying I've drawn this conclusion about the Earth because there is no experiment that proves this. When there are experiments that have proved that thing that you're just saying isn't true.
Can you provide a single one?
Yes. Google is your friend. Go look on Google. Velocity. Go look on Google. I'm in my garage.
You're saying go look on Google.
Yes.
But I'm telling you there's none. You can't find one.
Okay.
Why would I look on Google for something you can't find?
What are we looking for?
So we're looking for evidence. The question is, the accusation is, the claim is, that the thought is that when we go outside, we see the ground is not moving. We look up, we see these things moving, but there's no one has ever proven that the Earth is in motion. It seems flat and still. Okay, but the question is, the accusation is, the claim is, that the thought is that when we go outside, we see the ground is not moving. We look up, we see these things moving, but there's no one has ever proven that the Earth is in motion. It seems flat and still. Okay, but no one's ever proven otherwise.
Yes, it doesn't prove anything.
Who's the
so
one?
It's not proof of Earth rotation. That was the original question.
It's a demonstration of it. It's an evidence for Earth rotation.
I mean, that is all we can do. We can gather evidence.